what we can do if we apply a clustering algorithm on a particular topic. And the topic was the Climate Change Report 2022, Impacts, Adaptation, and Vulnerability. And we downloaded the 3,600 pages here, and we performed a cluster analysis, a semantic cluster analysis. And I showed you that I have here my BERT model, my sentence transformer BERT model. And as I told you, it works well for me to model all MPNet base version 2. I have it here on a Colab on my CUDA. And then we do some model encoding my sentences very easily. This is done if you just speed comparison. It took about 5 minutes on a K80 on Colab and just about 2 minutes 30 on a T4 Tesla. So if you can get a T4 on Colab, that's really worth it. And then we did all the fine tuning and we did all the embeddings. And as I told you here, we have our UMAP embeddings. This means we have a beautiful topological structure. We use the UMAP Python package. We reduce it. As you can see here, I had a reduction to 48-dimensional topological space. And after the UMAP, what we do, we have a cluster algorithm. And I use here the beautiful package HDB scan. It's really good. Auto claims it's better than k-means, and I have to tell you, it's great. Just do a little bit of parameter tuning, and it is really, really gorgeous. And what we got is, hold on. What we have officially are the figures like this one. I don't know what you can see. I can see nothing about this, and I thought, hell, can I use sentence embedding to get some information from out of this? Because if these are the main figures, I mean, come on. I mean, I can look at it, but I hardly get it at first glance, what it is all about. So what we did a 3D plotly. And here, you know, Network X, Matplot, all the different plotlies, Network X. And what we finally ended up with, and here we go now. This is again here, the full report. Hold on a sec. There's 3,675 pages here. And as I showed you last time, and this is it. Now, I had some reply from you, viewers. And the first one is, your spheres are too small to be visible on an iPad. So, okay. I hope you are now happy. These are my spheres now. It's really big. And the other one was, hey, what is the top 10 clusters? It's nice to have the top 56 clusters, but what are the top 10 I can remember from this report? What would it look like? And this is exactly what I have done here. I did a little bit further fine-tuning. At first, what we do is we get rid of the noise. So we have only the valid cluster structures that we have here from sentence embedding with UMAP, with HDB scan. And then we do away with University Press and Cambridge University Press and the Journal of Environmental something. We get rid of this too. And then, of course, there's also about the COVID pandemic, about the disease. Now, if we deactivate this cluster also, as you can see, yeah, as you can see here, for example, the cluster is here, the cluster is here, but remember, the cluster has been determined in a 768-dimensional topological space. So if you think now, hey, this is not a cluster, this is just some separately distributed clusters. No, in a higher dimensional, more precise representation, it was identified as belonging to one cluster. And now there you have it. These are the top 10 if you want clusters. And as you can see, the major one here I did with the really huge spheres. And then if it gets less and less, it gets smaller and smaller. But I think it gives you a good idea what we are talking about. These are the top 10 semantic clusters of our 3,675 pages of IPCC. And what you're asking for is, what is it? Okay. First one, let's just get rid of it. is heat related. Heat stress, urban heat. Gee, you hardly see it. Let me find another perspective that we see it. You see, this is switch on and off of heat stress. Next one would be sea level rise. Now, if you're living in New York, right next to the Hudson, you're interested in sea level rise, or California or Florida especially. Sea level rise. Wow, sea level rise is quite some huge chunk of topics that they covered here and that integrates in this way. Next one is sea ice, polar region, and aquaculture. This is the bright green one. I can show you here. Also very intermingled. Next one is flooding, water resources, but also water scarcity. And this is the light blue one you see over there. If we switch it off, we are left only with extreme events, climate change, warming levels. And this is the little green one here intermingled over there. We got rid of this one. And then we have food. Food is extremely important. I will show you in a later video about it. Food security, food systems, adaptation to change. If you get rid of this one, you see, my goodness, food is really encapsulating all other clusters. Food system and food security is a primary concern for our future, and it has been intensely described in this report. Let's switch it off. Then we have biodiversity of ecosystems. Let's make it simple. I don't even see it. Yeah, over there. We are right next to it. Should be better. You see, it's gone now. And then we have tropical forest, the tree mortality, and tropical forest singular. Where is it? Oh, it's over there, the red bulk over there. This is the tropical forest cluster. We switch this off, and then we are left with two dominant cluster, if you want. And there we have the resilient development, the climate resilient development in light blue. You can see how how close it's attached to the other huge cluster, to the biggest cluster here. And if we get rid of climate resilience and resilient development, what are our future actions? And if you switch it off, you see here, this is what we are left with. This is the biggest cluster of our top 10 clusters about IPCC. And if you make a deep dive into, oops, let's bring it back in focus, into this, you can see here, this looks like a subcluster, no? Let's get a little bit, switch off. Then, oh, wait, there. This could look like a connected component in graph theory of a subcluster. And also here, if you have a look here, where is it? Yeah, there, this could be a subcluster, this could be a cluster, and this could be another cluster. So you see, if we reduce it, and I adjusted the parameter so that we only have 10 clusters, the top 10 cluster. We have now the cluster here with decision making, adaptations, the options we have to adapt to climate change in all different areas. And then we also have the topic of urban climate. And if you think that half of the population is living or will be shortly living in cities with a growing trajectory of urban habitants, there you can see another cluster. So you have 3, 4, 5 clusters maybe here. Urban climate is, of course, thinking about options that we have for climate change adaptation and decision making for our future. It is interesting. So I hope that you are satisfied with the size of my indicator bubbles. But since we are talking about this, let me show you something else. If we have this, and I don't know, I think it's about 10,000 sentences. And those 10,000 sentences are just about this cluster here. And it is cluster number 10 in my. And if I go down and I try to break up this cluster in subclusters, there are different ways you can do this. And you might say, hey, this looks completely different. Look, this is only one connected component, and then we have here a cluster that's close by. Doesn't look at all. Well, it's exactly the same amount of sentences, but I refed it into the sentence transformer to achieve a higher precision. But what I did, and I showed you here about the code. Let's just go back to the code. Where's my code? You have so many things here. UMAP, subcluster. I've written something for subclustering. So what you do? Subcluster both clusters. Then if you cut between clusters, heaven's sake, here we go. And as you can see here, I did another UMAP, another dimensionality reduction algorithm performed just on this. Here we have it, 9,789 sentences. So again, I took only this subset of my, I don't know how many sentences, so let's say 10,000 sentences in 768 dimension. But what I have is that I can make this reduction to 48 dimensions and then go with my, where are we, with my cluster algorithm, or I can take it directly out of the 768 dimensional bunch. And this is exactly what you see here. If I take the 48 dimensional representation of the sentence embedding from my sentence transformers, this is what you get if you start the cluster algorithm another time. And it looks different, of course, to this representation. Well, surely, because it has a completely different boundary condition set for the system. But what I would recommend and what I did here is, as you can see here, those 10,000 sentences, now I started from all over again. Those 10,000 sentences that are exactly here, my group here, decision-making, adaptation, options, urban climate, my group number 10, I fed them into the sentence transformer, sentence embedding, right in 768 dimension. I ran through all of the algorithm again. So the first, this cluster here is now in detail with full accuracy in a 768 dimensional topological embedding, is now subclustered into these parts. And if I get rid of the noise, you can see here a very beautiful cluster algorithm. Here you can see with the little green balls here and the orange area that we are calculating in a 768 dimensional space. And if you break it down to 3 dimension, of course, you lose a lot of information about this. But you see that there is a higher dimensional bridge if you want. And also you see that there is a connection to the red cluster, as you would suppose, because here we got this in our mega cluster structure of the top 10 mega clusters as one cluster. And here you have them. So let's go through them step by step. The first one in orange here on the right side is urban climate, urban areas, cities, settlement, adaptation, change of adaptation for cities. Here we have them. Then we have over there, we have the red ones. The red one are impact of climate, impacts of climate change, the social protection, the change impacts, and climate change impacts. As you can see, I have not just bigrams, but also trigrams calculated to get a little bit more of a higher level semantic information. And these are the red ones. So we have here the cities, and here, if you want, then we have some social protection and the impacts we can expect. And then, of course, we have the green one. But let's switch now to the other side, where we have here this little ochre. And here in ochre we have, let's switch it on and off. we have the observed impacts, the projected risks, the high risk, the risk management. This is in this area of the cluster, a subcluster. And in blue, we have the decision making, the deep uncertainty, the increasing confidence, the confidence level, everything that is connected with this one. And then we have again the core of the cluster, if you want, decision making, adaptation, our options that we have given in this area, in this interlink from urban clusters, social impacts. And we have here the response, the finance of the adaptation, and everything here is in this cluster. And if I remember correctly, it's about 5,000 sentences just here, the green subcluster. So again, following your criticism, I increased the size of my spheres. I presented you the top 10. Let's switch it on again. Come on. Anything? Yep, here we go. So these are the top 10 clusters. And if I switch off the noise, again, this is it. This is the cluster structure you get. Each dot, each sphere is one sentence. So we have here all the sentences of the document clustered in a 768-dimensional topological space to understand the differences. And then we picked one with a 48-dimensional, which is not so recommended, I would suppose. And then I get the best results if I really switch to a 768-dimensional encoding. And remember, SBERT itself, if we go back, SBERT itself is in a 768-dimensional dense vector space. So there is a reason why the pre-trained sentence transformers have a certain amount of high-dimensional topological space dimensions, because the lower dimensional it is, you will lose, of course, some information. If it is just, as we had here, 3,600 pages, but it is important that if you really want to get some fine clustering, do it in the high dimensional space. I know it takes a little bit longer, but I suppose all of this took about 1 hour, 2 hours on Colab, pure compute time. And you get a real nice idea. You get a subcluster structure. You can do the subclustering for different parts, or you group two clusters together and you say, I want to see the interlink between two distinct clusters, what are in the vicinity of the border. You can have some borderline cluster structures, some filament structures in a high dimensional space. It is really, really interesting. But I think overall, if you have, a sentence embedding a sentence transformer model, it really gives you beautiful results. These are the top 10. I hope now you are satisfied with the size, with the color and everything. Have a good night, and I see you in the next video.